Yeah, we'll just wait maybe 3 more minutes, then we'll start. If you don't study at the Charité, it's not so easy to find this lecture hall, so it's one of the more hidden places. So I'll just wait 1 or 2 more minutes. Okay, I think we should start. My name is Ulrich Diernagel. I'm the director of the Quest Center for Responsible Research, and it's my great pleasure to welcome you here in this lecture hall, but we also have a live stream via, I think, YouTube. So also welcome to those sitting in front of their computers. I welcome you on behalf of the Einstein Stiftung and the Quest Center, but also on behalf of the Berlin School of Integrative Oncology. Now, this is a very special occasion. We are happy to present to you the 3 winners or the 3 category winners of the Einstein Award for Promoting Quality in Research. The award ceremony is tomorrow in the Bode Museum, and so we're very grateful that they are already here and that they are able to speak to us about their achievements, about their projects that they have. So what kind of an award is this? So I think it's a special award because we have lots of awards that award sort of scientific achievements in the proper sense, but very little we talk and honor work that is basically underpinning this scientific work, which is making work more transparent, more reproducible, more valid. And that's what essentially this award is about, and it has 3 categories. It awards globally in a category that is for the individuals and their achievements, and there is a category for institutions, which is rather broad category, as we will see, and also for early career researchers. We have an international jury, which is also global, and I have to say we have lots of very aspiring contenders for this award, so the jury has hard work to do, and the selection that you see today is very they have had very strong competition. This is especially true for the early career researchers. They had to the jury does a pre-selection, and then the 5 or 6 top teams, they compete with pitches, and the jury then selects the ones that they find best, and this is what we are going to hear about. So the award is kindly made possible by the Foundation and also by the Senate of Berlin. And it is partnered by the National Academy of Sciences of the United States, also by the Berlin University Alliance, by the Max Planck Society and Foundation, and also by the publishers Nature and PLOS. So just as a short announcement, so if you know someone who might qualify, even yourself, you just check out the website where our nomination is it's open until April 30, so you can nominate now because it works via nomination. Just a brief housekeeping. We will have the three talks in sequence, and then we will have, of course, a round of discussion. Those of you who are in this room, of course, can ask your questions or comments directly. For those that are online, we have a Slido where you can type your questions, and we will read them to the presenters. So without further ado, I'd like to get to our first speaker, and that is Elisabeth Bik. She's the winner of the category, the individual category. Just a few words. Elisabeth obtained a PhD at Utrecht University. She's initially a microbiome researcher, worked at Stanford and also in biotech, and I guess this is already where she got into contact with work that, let's put it this way, aroused her scrutiny and her interest. And she more and more got into this, first in her free time, screening the published literature for suspicious images. And many of you know, I think, know her name and know her work because she was actually instrumental in singling out very problematic cases, even cases of fraud, and many retractions. Not enough, I have to say, but many retractions have followed from this work. And she's now doing this freelance, basically, crowd-funded also. And she also consults, I think, journals and those interested in scientific integrity issues. I will read to you what the jury had to say about this, the justification for selecting her. Elisabeth Bik's work as a data sleuth is vital to science self-correcting nature. She has identified over 7,600 potential cases of research misconduct, and despite facing harassment and accusations, remains a strong advocate for research integrity. Through her blogs, Microbiome Digest and Science Integrity Digest, she champions rigorous standards and shares her love for microbiology, science communication, and research integrity. She sets a powerful example for aspiring scientists and the entire community, encouraging a commitment to transparency and integrity. And I think that's a very fair summary. So, Elisabeth, the floor is yours, and you can take over.
Thank you so much. Thank you so much. It's such an honor to be here today. I want to thank the Einstein Foundation, the nominators, jurors, sponsors, organizers that brought us all together in this beautiful room where I'm sure there was a lot of teaching about science, hopefully all good science, not science misconduct. What of course we'll be talking about today. So I worked at Stanford, and I quit my job at some point to work full-time on science integrity. Because I quit my job and I work as a consultant, my disclosures are basically how do I make my money. I receive consulting and speaker fees. I'm being supported by Patreons, so those are people who donate small amounts of money on Patreon, and that allows me to do this work. I also have worked for a fraudulent company, Ubiome. I'm not going to talk about that, it's its own story. But also when people talk about my work or think about what I do, is they want to know how I started doing this. So I was working at Stanford, and I heard about plagiarism. And I thought, let's just take a sentence I've written into Google Scholar between quotes and see what comes up, only expecting my own paper to come up. But if you look at the image on the left, you will see a text that I found, and the text marked with red coloring highlights is 2 paragraphs I had written. Somebody else put their name on it. And not only that, they had also stolen text from other people. So it was plagiarism. They had stolen text from many other people, put it together, put their own name on it. And I still remember how angry I felt when I saw that. Somebody had stolen my sentence. And I'm still fueled by the anger that I felt on that day. I felt this was so wrong to steal somebody's text, passing that off as your own. That should not be done. That is not how we should do science. I worked on plagiarism for a couple of months, and then by another coincidence, I found a PhD thesis that had plagiarized text, but it also had duplicated images. You can see that in the middle and on the right. The image that you see with this turquoise or cyan box, you see that on the bottom, you see that in the middle, you see this little dot there, you see the same photo here on the right, except it is a mirror image. You can recognize it because of that little dot there. These are Western blots. You might not know what they are, doesn't really matter, but I hope you can see that that image has been reused to represent a different experiment. And not only that, there was a third occurrence of that same blot that you can see on the right, in the middle. And then I found another one of these Western blots that I've marked with red boxes that also had been reused. So this PhD thesis and its chapters had been published, had lots of duplicated images that were inappropriately duplicated. These were the same photos, but not the same experiments. They put different labels on it. So again, an example of people trying to cheat in science. And that made me even more angry, and I thought maybe I have a talent for these things. I love to spot duplications. I love to spot patterns in floor planks or in bathroom tiles. And I'm also very bad in faces, so I guess it's sort of the trade-off that I have. But maybe I should use this slightly unusual talent to just focus on image duplication in scientific papers. I had not expected to find a lot, but again, I realized what made me so angry when people perhaps cheat in science is that when we, as scientists, read these papers, we build our work on these papers. We look at these images, we look at this data, and we build on that work. So when we do science, we don't do science by ourselves. We build on the work of many generations of scientists that came before us. Maybe hundreds of years of science might be the basis of the work we do. So scientists build upon other scientists. Every publication is like a brick in a wall that we build on, that we layer new generations of scientists and publications on those old bricks. But unfortunately, even though we might trust each other, there is fraud in science, and sometimes just plain errors. Scientists are just like humans, we make errors, but some scientists are also, unfortunately, fraudulent. With the pressure to publish, some people might cut corners or might even do fraud. And so when we find bricks or publications that are not good, part of that brick wall of science could tumble down. And I feel as scientists, we need to warn each other if we find such a rotten brick, because other people could waste a lot of time and money trying to replicate those results. So I'm part of a growing army of science sleuths, as we are called, some of which are present here. Some work under their full name, some work under a pseudonym, because you imagine that criticizing other people's work is not always well received. Of course, I understand nobody's really happy when we criticize another scientist's work, but in some cases this could lead to harassment or even lawsuits. So there's a bunch of people who care about science in the same way I do, and actually flag papers that have all kinds of problems in them. And when we find such a paper, we post on PubPeer, and you will hear another talk today by Brad and Stell about PubPeer, one of the other prize winners of the Einstein Foundation Award. So PubPeer, as you will hear in the next talk, is just a website where we can post our concerns about specific papers. In that way, we can warn other people that there might be particular problems in these papers. And so we post on PubPeer and hope that other people then see and you know, maybe put certain question marks based on the problems and concerns that we find in these papers. I focus on images, like I already said, and I have here 3 examples of problematic images that you might find in scientific papers. And so starting from left to right, we have simple duplications, we have repositioned duplications, and we have duplications with alterations. So starting on the left, a simple duplication is where you see a bunch of photos, but 2 photos are identical. You see them marked with these red boxes, which are my additions. And so, but even though they have different labels. So it's an inappropriate duplication. In the middle, you see a repositioned duplication. In fact, you see 4 different photos, but they all overlap with each other. So they're not 4 different experiments, as the authors might want you to believe. These are all just photos taken from the same sample, just moved under the microscope a little bit. They all overlap with each other. On the right, you see an example of a photo that has been altered. So within this photo, there are elements that have been duplicated. So the photo itself has been changed. This is basically photoshopping. And you can imagine that if you think about a simple duplication on the left, that might be an honest error, while the repositioned, I think in this case, I'm not quite sure if that's an error. I'm not sure. If all 4 photos overlap with each other, you have to be extremely sloppy as a scientist to deliver such results. The photo on the right, that, you know, parts of tissues don't replicate themselves, so you can assume that this was deliberately done. Whether or not it was misconduct is a slightly different question, because maybe they were just trying to cover up a hair, or a crack, or whatever, maybe a label sometimes. In this case, I think it goes a little bit beyond that, just covering up something else. But yeah, this seems to have been done deliberately. So these 3 types of duplications might help a research institution that investigates allegations of misconduct in determining whether or not it was misconduct or just an honest error. So I'm going to ask the audience to see if you have the talent to spot these things. I'm not going to put anybody on the spot. And I'm just showing a couple of panels here. And this is an example of an honest, I think an honest error. You see 7 panels, but 2 of these panels are identical. This is not a very difficult one, I hope. Just raise your hand if you see. I'm not going to ask anybody. But most people should be able to see these, unless you're maybe at an awkward angle, maybe in this room. 2 of these panels are identical. I hope you got it right. Yes, you got it right. You all win awards. Yay. I do this game on Twitter and Blue Sky, and people can win emoji awards, and they love it. They're like, I already won 2 awards. They are really so happy with that. I also want to note, I reported this to the journal, and nothing happened. Nobody did a thing. This paper is still out there. You can download it and, you know, play the game yourself, maybe with somebody else. It's a fun game to play, but it's really sad, I think. Even though this might be an honest error, the editor didn't really care, I think, and this is still out there. We're gonna make it a little bit harder. So here you see a bunch of photos, and some of these photos overlap. So now this is a type 2 duplication error. Raise your hand if you see it. This is much harder, but some people might spot a talent. Just raise your hand if you see it. It's hard for me actually to see from here. But a couple of these panels overlap. I see some hands, some half fingers or so, but I'll show you the answers. So some of these panels overlap. And that again, I think the amount of overlap here would be a little bit too much to say, oopsie, we made an error, although in most cases journals, the authors will say that. So this was published in Nature, and it was corrected. I personally think that is not the best of outcomes. That's a lot of errors to make, I think, in a paper. So this type 3 duplications, as you can see here, are the hardest to detect. So you see two photos. Within each photo, there are duplicated elements. Raise your hand if you've spotted something. These are hard to detect in a room like this. And I have at home a huge curved monitor, and I'm actually in my monitor looking for these things. But maybe you spotted something. Let me give a hint. The easiest one is on the left panel, bottom right. You might spot something there. Just raise your hand if you've spotted something. I see some hands. Very good. And I hope you will never look at microscopy photos the same way again. Because, you know, I would say Houston, we have a problem. Because this is just, you know, this is not good. I reported this on PubPeer, you know, almost 2 years ago. Nothing happens in most of these cases, unfortunately. So I do this work for a while, and when I started finding these duplications in 2014, I wanted to know how often would you find these duplications. And so I'm slightly crazy, so I did a scan of 20,000 papers, as one does, you know, as a hobby. I went home, I had my full-time work, and at home, I was just amazed by these duplications, and I just wanted to know how often would you find this. And so I scanned 20,000 papers. I only looked at the images. I didn't read the papers. By eye, from 40 journals, 14 different publishers, and I found around 800 papers to contain such duplications. I only checked papers that had the word Western blot in it, to enrich for molecular biology papers. So it's not a scan of all literature, it's just focusing on biomedical molecular biology papers. They have a lot of photos, focusing on those photos. And they had to have duplications within the paper. I didn't look across papers because our brain cannot remember, at least my brain cannot remember that many photos. But within a paper, it's you know, you can just make screenshots of all the photos in your paper, and you can compare them to each other. So about 4% of the papers that I found had these duplications. I found 2 co-authors who were also slightly crazy and willing enough to accept my work, and they had to both agree with me. If one of them said, no, I don't think this is a duplication, we took it out of the data set. In that way, we calibrated each other, made sure it wasn't just my eyes seeing it. These were 2 experienced editors-in-chief, and they both had to agree with me. So we took about, I think in the beginning, about 10% we took out. They didn't, but some of these, I'm still convinced I'm right. So, but I did report all of them to the journals. We think that about half of these 4%, so around 2%, were done with an intention to mislead. It's hard to know for an individual case, but if you have 800 papers with problems, you can make an educated guess. Does that mean that 2% of all scientific papers has potential misconduct in it? We think it's an underestimate, because I only look at photos, I only look at duplications. If you are a really good Photoshopper, or you move your sample under the microscope a little bit farther, there's no overlap for me to find. So I'm really only catching the very dumb fraudsters, the tip of the iceberg. And so I think the real percentage of misconduct has to be higher than 2%. Also, if you think about line graphs or tables, or a lot of data is actually not a photo. It's much easier to cheat in a line graph, I think, than in a photo. That is before AI, because that changes the picture. All these papers were reported. Only 50% of these papers has been either corrected or retracted as of today, meaning that half of these papers, even if you wait 10 years and send a reminder, nothing happens in most of these cases. So half of the papers were not retracted or corrected. Nobody thought it was worth addressing. So if you think about, is science self-correcting? Well, only about 50%, I would say. The rest just seems to be, you know, nobody cares about that, except for some of us. I'm using now software to help me find these things. So I used my eyes 10 years ago. Now I'm using either Image Twin, Proofig, there's a bunch of other softwares. And thankfully, I get licenses from both of these software tools to help me find these duplications. You see some examples there of the same paper. This is a paper published in Science. This happens everywhere. And a famous Dutch scientist was actually the senior author. But both of these software tools also found what I found by eye. So confirming that it finds these things. And even better, because both of these tools also have databases, so they help me find even more cases of image duplication across papers. Let's switch topics a little bit. I want to talk a little bit about scientific paper mills, which are scammers that want to make money by selling fake or low quality papers to authors who need them. Very often these are people in countries that don't have a lot of money for science. Maybe they're hoping for a better future. Their career will be enhanced if they publish papers. But there's a bunch of people behind the scenes that make lots of money by selling these fake papers to the authors who need them. It's a growing problem. We don't even know how big it is. There were estimates that about 2% of all papers now might be produced by paper mills. But very often we see these papers, we just know they're fake. There's just no smoking gun. There's there's nothing we can capture them on other than just a gut feeling that it's probably a paper mill. So you have to be careful. We don't want to falsely accuse anybody. These paper mills use all kinds of methods. There's no just one paper mill. There's different models. They could fabricate papers, writing them on a template, basically rewriting the same paper over and over again, not just changing a molecule to another molecule, changing one cancer to another cancer. And sometimes we can catch them because they might sometimes reuse images from each other or make some dumb mistakes that we can catch them on. They might hire writers to write these papers. They might plagiarize papers or even synonymize them by rewriting papers and changing every word into a synonym. They might, of course, also use generative AI, because nowadays we might all have tried ChatGPT and it's wonderful. And you can actually steal somebody else's text, rewrite it by ChatGPT, and then publish it as your own. And it's really, really hard to catch these. So the paper mills are continuously developing new strategies. I'll show a couple of dumb mistakes that some of them have made. But I think by now, generative AI is so good that it becomes increasingly hard to catch these. And we need to worry as a scientific enterprise about what are we going to do about it? And yeah, I worry about that. So as an example, AI can generate fake text. It can generate text like these, and sometimes the dumb folks, the dumb fraudsters, might leave in a little trace for us to find. Like if you leave in your ChatGPT generated text the wording, as an AI language model, I cannot help you with that. So if you leave that in, we're like, aha, you use ChatGPT. That is currently not allowed in scientific papers. You have to disclose that. These things might change in the future, but sometimes you just see a lot of text suggesting that that text was not written by a human. Again, if you would leave out that text, we would not be able to catch it. And maybe we shouldn't worry about AI generating fake text as long as it produces something that is real. Maybe it will give everybody the equal chance to write something in English. If English is not your first language, it is actually a very useful tool. And maybe we shouldn't worry about that too much. I'm mainly worried about the ability of artificial intelligence to generate fake images. If you have been online, maybe on Twitter or Blue Sky, you might have spotted the rats with the giant balls and penis, which clearly is not anatomically correct or helpful. It wasn't that bad, but this paper had been published and we all had a good laugh. The image next to it, on its right, was from the same paper. It's not useful. There's nothing useful in these images. We cannot read the text. It doesn't make any sense. The text itself was also presumably written by AI. That's a funny example, but I'm most worried about photos. We know that these generative AI tools are getting better and better. It can generate images of people who do not exist. If you've taken the test in the New York Times that you see on the top left, you see these two images. The photo on the right of the woman with the glasses, that was an AI-generated photo, while the photo on the left of the man with the curly hair is actually a real person. Of course, they tossed in some slightly unusual faces to trick you, but I don't think we can tell these things apart anymore. Now, I'm bad in faces, so maybe for you all that is very obvious which one is the AI-generated image, but it's really, really hard to catch these. And it's even easier probably to generate some fake AI images of cells or tissues. So the top row here are real photos. You train some AI model and it generates the photo on the bottom row. These are all fake, they don't exist. But these photos, I would fall for these photos. I might think that they're real, and each of these photos is unique, so I cannot use my software or my eyes to catch them. There's no duplications in these photos. They would pass for real, and it would be very easy to generate a fake data set with these types of images. So what can we do to ensure that photos we see in scientific papers are real photos? I think this is something to think about. Maybe we'll hear about it in one of the next talks, looking at this site. But I think in general we need to worry about it. Just as an example, this is a more primitive form of AI. This is what we call the tadpole paper mill. We found a set of 600 papers that all use the same background. These are Western blots. They look not very realistic. If you've ever done a Western blot, you can see something is off. But the way we could catch these and know that they were fake is that the background, if you enhance the background of these blots, you start to see all these little dots. They're all the same. You need to maybe sit on the front row to actually see that. But we could catch these and we could recognize these backgrounds and know all these papers were generated by the same source. They generated them by sort of having a library of bands and plopping them all together. But the dumb fraudsters made the mistake of using the same background. That is why, we could catch them. Now, of course, they do a much better job. So we see images that look a bit off, a bit strange, but we cannot catch them anymore. So if people could do this 5, 6 years ago, now, of course, the technology is much better and much harder to catch. So why do people do misconduct? Just mentioning science misconduct, the rewards to do science misconduct are really high. Your papers look better, your career is better, you'll have success, you'll have your grant. Unfortunately, the consequences are very low. So very often there's the investigations take a long time, journal editors don't do anything. And so very often there is nothing that happens. And so it's frustrating to see these papers with photoshopped images and see that these people are still employed and have big jobs, big salary jobs. Nothing happens. It's like traffic without a chance of being pulled over by a cop, or sports without a doping check. That is what science is currently. We need more doping checks and more cops pulling over cars and ticketing people who drive too fast. And then there's the cost and consequences of science misconduct. So misconduct is bad on all fronts. It's bad for scientists, it's bad for science critics, and it's bad for science. So for scientists it's bad because it leads to all this wasted efforts trying to replicate papers that didn't happen. False hope for patients. I've worked on, together with Charles Piller, on Alzheimer's fraud. It's just frustrating to see people enroll in trials that turn out to be based on fraud. These people could have had an enrollment in a different clinical trial. You give people false hope, and it's a delayed progress for science. And there's all this collateral damage of other people who were authors on these papers who have been involved now in the misconduct. For science critics like me, it can lead to harassment, to lawsuits, legal threats, damaged careers. Very often we're seen as troublemakers. This is one of the reasons I quit my job, because at least they cannot really harm my career, but because I don't have a career. But I could still be sued, even if I'm right. And so I'm part of the team that set up the Scientific Integrity Fund, where we want to help people who are legally threatened by if they criticize other people's papers. And I'm using the money that I got for the Einstein Award. I have used that, I put that in the, I guess it's called the Elisabeth Bik Science Integrity Fund, because I want to help other sleuths like me by, for example, providing them with money to travel to a conference. Most of us do this work. It's not really often encouraged by our employers. And so I want to give especially young folks a chance to travel or to perhaps buy some software or to do anything that can help them with their sleuthing work in order to make science better. And then finally, it's bad for science because you can all leave this room and say, well, all science is fraudulent. I'm going to give up on science. And I do not want that to be the message. The message is, yes, there is fraud in science, but we need to do better. We need to tackle that. We need to ensure that people who do science fraud are being caught and dealt with. Because we want to take out that rotten apple in the fruit basket. But there's so much good fruit in that basket. There's so much beautiful science. We need science to solve all the problems in the world, like pollution and pandemics and climate change. We need science for that, but we have to know which science to trust. And I do hope to play a role in that. So thank you for your attention. Is it? Oh.
Okay, thank you very much. Also congratulations again for receiving the award and also for the brilliant idea, I have to say, to put the prize money into this fund. And that's really also in the spirit of those who came up with the idea of this award. So it's creating more. That's very nice. So I just need to switch now to the next presentation. And this is number, oops. Okay, I think we're getting there. Okay, so our next awardee is actually an institution, if you wish. It's PubPeer. But of course, behind every institution, there are people. So I would like to introduce Brandon Stell. He is an electrophysiologist or a neurophysiologist, I should rather say. He investigates sensory processing in the cerebellum. He's a co-leader at the cerebellar neurophysiology team at the Centre National de la Recherche Scientifique, the CNRS, at the Université Paris-Cité in France. I'm sure he would probably prefer to be at a scientific conference and talk about his science. In fact, there's a lot of, I think, interesting history of neurophysiology around here. Not only history, even today there's good neurophysiology, but you're not here for this because actually he is here because in 2012, together with the help of developer George Smith and his brother Richard Smith, and then joined by Boris Barbour, who is also in our lecture hall here, they founded PubPeer. And they initially founded this as kind of an online journal club. In fact, if you go to the website, you still see the online journal club thing, which I think is almost a bit of a pity that we now think of PubPeer mostly as a medium to expose fraud, which it is, and it has been extremely instrumental in this, but it is also, I think it could be, and it partially is, the solution to a huge problem which we have in science, and that is that we have publishers that kind of make their profit on our work, and we are obscuring actually the scientific discussion. So, and that's a very personal view, I think, with preprints and something like PubPeer, we could do away with the publishers, maybe even with the fraud that we have seen. But that's for the future. So far, we are very happy that PubPeer exists. It is estimated that 19% of all retractions of papers worldwide are, in fact, have been prior to retraction discussed on that site. And that, of course, I think is the main reason why it was chosen by the jury for the institutional award. And I would like to again also read to you what the jury had to say about it. And so the jury said the international award PubPeer, PubPeer, occupies a unique niche in science communication, enabling rapid public post-publication peer review. Its impact has grown exponentially. It has helped identify flaws in the work of eminent scientists, combated the scourge of fraudulent paper mills, and fostered the emergence of an international multidisciplinary community of research integrity experts. So it's my great pleasure to welcome Brandon, and the floor is yours.
Thank you, Ulrich, for that very nice introduction. This is kind of not fair. Normally, the rock star is supposed to go at the end of the day so that the other acts kind of build up to it. So sorry to let you all down after Elisabeth's great talk. I would like to thank obviously the Einstein Foundation. This is an enormous award to our website and to the users of our website. The website's called PubPeer. We started it in 2012. I now run it with Boris Barber, who's up here. He can maybe raise his hand so everybody can see. Yeah, there's Boris. More shy than I am. And that's not true, actually. And so the idea of the website came from analyzing papers throughout my scientific career. This usually happened in journal clubs. So for those of you who have not been involved in a journal club, this is kind of an informal meeting of scientists, happens regularly, often in a department, where somebody presents an article. A junior scientist often presents an article, and we all go through it figure by figure in really close detail, analyze the paper from A to Z. And so started going to these things when I was an undergrad, and so I've now been going to them for about 20 years, and I don't think I've ever left a journal club where we said the paper was fine, everything was perfect. There's always some issue with an article that we analyze. And as an undergrad, I was really struck by this. I mean, sometimes it was really minor issues, but sometimes it felt like, there seems like there's a major problem with this article that was published in Nature. How can that be? I mean, do all these articles really have a problem? And if the authors were here, maybe they would say, well, look, you guys misunderstood something, right? And if not, if there really is a problem, then it felt like, well, we just know, the people in our journal club know about this now, but other people are using this information. It would be great to get this information out to everybody who's interested in this article. And so that was kind of I thought, well, where's the forum for discussing science? And there wasn't one, right? And so we decided to build a very simple website that just allows us to discuss publications in fine-grained detail. And so these journal club discussions are important because these are articles that we scientists are basing our future research on. But these articles also have bigger impact on society in general. I'd just like to highlight this one example here. Elisabeth mentioned a few articles, but I'd just like to, I think I don't know how to use this pointer. Oh, well. It's this one? Oh, yeah. Oh, wow. Uncontrollable. Okay, so this is data from Andrew Wakefield that was published in The Lancet in 1998. I'm going to have a hard time wielding this laser, so I'm just going to, I'm going to forget it and just describe it. The article was published in 1998, and it was based on, it was eventually retracted. So 10 years later, it was retracted because it was based on debunked science. Andrew Wakefield eventually lost his medical license for this. But the claim of the article was to make a link between autism and the vaccination for measles, mumps, and rubella. Okay, and so this link was based on fraudulent data, and the article was in the literature for 10 years, about 10 years. And in that time, concerned parents, obviously this is around the time of the internet, concerned parents are hearing about this link between measles, mumps, and rubella vaccine and autism. And what's plotted in the yellow bars here is the vaccination rates in the UK at the time. So Andrew Wakefield was a British medical doctor. And what we see over time, maybe I try this one more time. What we see over time is that these vaccination rates are decreasing. And if we look at the rate of measles infections, it shoots up. The two things are obviously linked, and this is an example of how a single article, if it's based on fraudulent data, if it's false, can cause major harms to society. Okay, because of this article, it was used by, it could be used by, it's unlikely that the parents of the children are reading this article, but the reference to this article on social media and stuff is influencing a lot of people not to be vaccinated. And so, you know, the important thing here is that there's fraudulent data and that there was this 10-year span where this article was in the literature, wasn't retracted, and could be used by people who wanted to make the case that there was this link. So that's one example of a bad article and its influence on society. How big is this problem? So, you know, we think from looking at Journal Club articles, or articles in Journal Club, that there is an extensive problem. And around the time that we launched the website in 2012, the head of the NIH at the time published a report in Nature, a commentary in Nature, where he's quoted as saying the complex system for ensuring the reproducibility of biomedical research is failing and is in need of restructuring. So it seems that there is a problem. It is a big problem. We're not the only ones to notice. The head of the NIH has noticed. How can this be? What is the source of this problem? Elisabeth mentioned that this is likely to be due to the fact that these articles are not meant just to communicate science to other scientists, but it's also kind of a career currency. These articles are used as stepping stones to build a career. And so publishing in the best journals and publishing often can really lead to career success. So much to the point that this alternate universe has been created that Elisabeth mentioned, where there are factories producing articles that they hope nobody will ever read. It's just to cash in for a career promotion. Nobody's ever going to read these articles and try to base science on it. It's really just to build your career and use the article for the currency that it's being valued as. And so the idea of the website is to kind of, you know, focus attention away from where an article is published and how many articles are published, but what really is said in the article. So that's kind of the background and the motivation of the website. I'd just like to take you through it quickly for those of you who don't know it. This is the front page of PubPeer. Very simple website. So there's a search box at the top and a list of articles that is below that. And so these are articles, this list here are articles that have comments on PubPeer. And if you come to PubPeer and you don't see the article that you want to comment on, if it's not already in the list, well, every article is published with like a little serial number called a DOI or a PubMed ID. And if that serial number is taken off and put into the search bar, then PubPeer goes out and finds that article and brings it in so you can leave the first comment on an article. So that's, I mean, very simple. It's just a discussion website. And if we click on one of these articles here, we go to the page. So this is one that was left in the last few weeks. And just like to highlight a few pieces of information here. So we have the title, you know, so we know what article we're talking about, who the authors are. And somebody a few weeks ago left this comment on this article here, and what you see is that there's a name associated to this, but it's a name from the tree of life. So it's not somebody's name, this is a pseudonym that we have assigned to this person. So if you come to PubPeer and you want to leave a comment, but you don't want to do it in your name, and there are very good reasons for not wanting to leave a comment in your name, then you can choose to leave an anonymous comment, and we will assign an anonymous username to you, and we'll give you a code so you can come back and use that anonymous username in the future if you want. So that's what happened here. Somebody left this comment on this one article. And the other piece of information is that, it's kind of hard to see on this screen, but there are these little check marks up next to the author's names. This signifies that we have on file an email address for the authors. So either we took that off of the PDF of the article, or a user has supplied that information and we have verified it. But what that means is that once the comment is left, an email is sent to the author so that they know somebody has left a comment on their article. And in this case, if we scroll down the page, we see that a few weeks later, an author came back and responded to that article. Okay, so this is kind of the dream conversation that we are looking for on PubPeer. It's not the best way of saying that. I mean, one of the uses of PubPeer is to have these sorts of scientific conversations. And it's a discussion where somebody read an article, they think they saw a problem with it, they left a comment, and the author comes back and responds to it. And so you might be thinking, well, okay, this anonymous commenting, I've seen this on YouTube, and this is an absolute disaster. People just say horrible things. And we thought when when the first version of the website didn't have anonymous comments, but it was, everyone who discovered it basically said, yeah, I'd like to leave a comment, but I don't want to do it in my own name. So we thought, okay, maybe we can give anonymous commenting a go on PubPeer. Maybe it'll be different because these are not cat videos on YouTube. These are scientific articles that people have to make a scientific argument about to convince other scientists. And so we allowed anonymous commenting to see how it would go, and we built in several different safeguards to make sure, try to make sure that the anonymous commenting didn't get out of control. I wonder if this works better. No. And so we have different layers of security here. And the first one, the biggest golden rule of PubPeer, is that comments have to be based on publicly verifiable information. So this is usually a figure in the article. Look at figure 4A. I think I see a problem here. Everybody can go to the article and look at figure 4A. What you can't say is, oh, I heard in Brandon Stell's lab they don't wash their glassware very well, and so that's probably why they're seeing this crazy effect. That's rumor, and that's not allowed on the website because it's not publicly verifiable. So comments are centered on discussions that everybody can verify for themselves. Comments are moderated, so we have a small team of moderators. Basically, every comment is eventually seen by a moderator. Our moderation team at the moment is small, and so that means that they're not experts in every single scientific field. So it's not a thorough scientific review of the comment. It's to make sure that it's abiding by our golden rules of PubPeer. And then, of course, there are facilities for reporting abuse. There are these report buttons on the website, so if you see a comment that you think is not abiding by the rules or has other problems, you can report it to us, and the moderators can have a look and can remove the comment if it needs to be removed. And of course, the authors have a permanent right to reply. So that's the other thing that keeps the conversations productive, is if somebody says something that is mistaken or confused, the authors can immediately respond and clarify things. And of course, we encourage those authors, when they respond, to show original data right on the website so that everybody can see it. And that has built this kind of community of people who are interested in using the website. They have an interest, so we have a pretty loyal following of users on PubPeer, and they have an interest of those comments that they're leaving and the other comments from other people of being accurate. So we do have a lot of community surveillance also. Somebody who's a loyal user of PubPeer has an interest that the other comments are also good, because that puts more of a value to their comments. So if they see one that is not abiding by the rules, they will report it to us, and we can take action. So this is an example of another type of comment that we have on PubPeer, and this is the overwhelming vast majority of comments. This one, maybe, no, this is not one of Elisabeth's, I think, no, okay. And these are the sorts of image issues that Elisabeth mentioned. You can see here, this is very similar to some of the stuff that Elisabeth pointed out. There's all of these, so all of these different rows are supposed to be different data with different proteins. So there's C2, there's NFK, BIE, and these bands are supposed to be different. This pointer is really unwieldy. So what we want to see from C2 here is that there's this purple arrow that comes back around over here, signifying that this image is the same as that one. And what you can see is there's this little speck down here, similar to what Elisabeth pointed out in her talk. This has been rotated, okay? And so somebody went to a lot of trouble to kind of piece together all of this little data to make it look like there's new data. What's interesting about this is that this is an article by another person who is interested in making a link between vaccines and autism. This article was published in September 2017, September 5th. The first comment appeared on PubPeer on September 20th, so almost 2 weeks later. And by October 10th, the article was retracted. So this stayed in the literature much less long, a lot less long than the Andrew Wakefield article, and could not be used on social media to say that there is a link between autism and MMR. So this is, I think, a great example of how potentially, because this stuff was all public on the website, the journal had to take action a lot quicker than it normally would have taken. So that's the other type of comment that we have on PubPeer. The website launched in 2012 and is continuing to grow and grow and grow. We now currently have 330,000 comments on the website. And we're getting about 8,000 comments a month at the moment. This might be a little bit difficult to see because of the bad colors I've chosen, but this is a ratio of our anonymous comments in the bottom left to signed comments. So the signed comments are in the dark gray, and the anonymous comments are in the light gray, and it's overwhelmingly anonymous. So most of the comments that we receive on PubPeer are from anonymous users. This makes total sense to me because if you're going to criticize another scientist's work, most of the stuff, most of the review these days is happening anonymously. And so if I criticize somebody else's article, there's a very decent chance that they could be reviewing one of my articles or one of my grants, or could, take reprisals in any other way. And so there is a real incentive for scientists to keep this anonymity when they're criticizing other scientists. And so I think that's why the majority of our comments are anonymous. An interesting trend, so as I pointed out before, we keep track of author comments, and we see that the author comments are growing. There's a recent big spike in author comments. I think that this has to do with the fact that as PubPeer grows and as it wins awards from the Einstein Foundation, gets more recognition, authors are also recognizing that a comment on their article on PubPeer is something that they have to take into account. They can't just ignore it anymore. And a calculation that Boris did recently, which Ulrich mentioned, we find very interesting, is that, so Retraction Watch, another extremely impactful website in our little field here, keeps track of all retractions in science. And Boris looked at, and they have a database of all those retractions with the dates of the retractions. And he looked at the date of the retraction and whether or not that article had a comment on it on PubPeer before the retraction. And what he found is that 19% of all articles that are retracted have at least one PubPeer comment before they were retracted. So it looks like the website, discussions on the website are having an effect on the literature. So where do we want to go with this? Well, we want to continue to build this independent body of scientific evaluation that can be used by evaluation committees. Ulrich alluded to this in his introduction, but we really feel that if we can grow this body of evaluation, this independent body of evaluation, if a scientist's reflex after reading an article is to make a comment about that article, then that body of evaluation is going to grow and grow and grow. And if an evaluation committee has access to that, then maybe that evaluation is going to have more impact than just what journal the article was published in. What does the community think of that article becomes more important than where was that article published and how many other articles has that author published. We have the power to make this community assessment, to build this body of evaluation. If we do that, maybe the incentives for creating the fraudulent work disappear. It's no more, it would no longer be interesting to create fraudulent work if later on PubPeer there's a discussion saying that this work is not interesting, if that's what really counts. So we're trying to grow that, and thanks to the Einstein Foundation, we have recently implemented awards that we give away every month now. We award a quality comment on the website with $1,000. So there's now a major incentive. If you're a student or a graduate student or a postdoc or a young scientist working in France where the salaries aren't very high, $1,000 is a big deal, right? And there's a real incentive that if I write this comment, if I go to my journal club, I come back and I write what we said in journal club on PubPeer, I could win $1,000. And so that's a direct result of the award from the Einstein Foundation. And we think that helps, but we're still just a little website. And I really think that if these awards could be grown and other people could give them. Imagine if, I don't know, Max Planck or the NIH gave a grant. It doesn't even have to be monetary. It gave some sort of recognition to say, this person has contributed substantially to post-publication peer review. If a student or a postdoc or a young scientist could put that on their CV just that they got some recognition from one of these big bodies, that's a major incentive to do that. And I think it doesn't cost them much to do that, and it could really help grow this body of evaluation, which could completely redirect the incentives in science. Okay, so that's the end of that rant. The other thing that we have done is we have created institutional dashboards. So these are just basically ways for institutions or journals or publishers can subscribe to get alerts when there's a new comment on their article. So if you're Harvard, you can subscribe to PubPeer, and anytime a researcher, anytime an article that is published with the affiliation Harvard attached to it, the institution can get an alert. And so institutions, journals, and publishers can keep track of the comments and act on them much more quickly, be aware of those sorts of the fact that there's conversations there. And Elisabeth also mentioned that we have created these browser plugins, which I think is a major component of the website also, because if there's a discussion on PubPeer, without the plugin, if you go to a journal website, you have no idea that this discussion is happening. So to kind of bring information to the journal website pages, we created these browser add-ons that it's just a tiny little simple piece of code that you can install into your browser. It sits there and it does absolutely nothing unless you browse a page that has an article that has comments on PubPeer. Then it gives this little alert, these little green alert boxes show up to say, hey, this lab website that you're browsing, because you're thinking about doing a postdoc there, has a list of articles, and one of those articles has a comment on PubPeer. So you can go see what does the community think of that researcher's article. Or if you're browsing PubMed, it'll appear also. Right, so here's an example of it appearing on PubPeer. So that's kind of the website, the background of the website, and some of the other developments we've put on the side of it. The website is run by the PubPeer Foundation now. So this is a nonprofit in California, which has myself, Boris, of course, and Ivan Oransky as the directors. It's a very small operation. Our major costs are we have a part-time developer and legal fees. And the idea is that this nonprofit association, this is not a startup. Nobody's trying to become billionaires from this website. This is by the community, for the community, to improve the way that science is communicated. I think that's my last slide. Yeah. So thank you for your attention.
That's absolutely great. I think it's a brilliant initiative, and I'm quite sure that, let's say, in 5 to 10 years, if we look back, we will know that this has been transformative for, I think, the entire system. So I think that's great. Also, for the first time, I heard about the initiative with the $1,000 initiative. Again, thank you very much for using the foundation money in such a productive way. I think this is great. So we're coming to the last presentation, and this is a presentation that is by Helena Jambor and by Christopher Schmied. Let me just briefly introduce them. So Helena is an associate professor at the University of Applied Sciences of the Grisons in Switzerland. She is a molecular biologist and RNA scientist, and specializes in biological and medical data visualization, and is also a trainer and consultant for life science data visualization. Christopher Schmied is a senior research data scientist at the Leibniz Institute für molekulare Pharmakologie here in Berlin, and lead data scientist at the EU Open Screen, which is a non-profit European research infrastructure consortium for chemical biology and early drug discovery. The reason why we have them here is PixelQuality, and PixelQuality is sort of the product of their mind, which made them the winners of the ECR award. Both of them, they started the initiative in 2021. It's a very recent one. It aims to develop and establish best practices for publishing images. And again, the jury, what they had to say about this, PixelQuality confronts a pressing issue, the need for reliable image data in research. This initiative, uniting nearly 150 researchers, has established guidelines for clarity and reproducibility in research images. The project now seeks to implement and educate the adoption of these guidelines, as well as adapt these resources to the new challenges of AI-assisted image processing. So maybe just one before you, is it Helena? Are you starting? Just before you start, one comment, because it appears that the foundation is mostly interested in maybe fraud, image manipulation, rectifying the scientific record, because all three winners this year have kind of a link to these issues, and that's, I think, one of the reasons for this is, of course, that this is such a pressing issue. The other reason is that this year we just had the most brilliant nominations and projects were almost by chance, I would say, concerned with this topic. So there's no, the jury did not have a year where they just wanted to look at image truth or so. So thank you for being here, and I think you're sharing your talk, and Helena will start.
Thank you. Yeah, thank you very much. I, of course, want to thank we want to thank the foundation, but we especially want to also thank you both for having actually a scientific side to the awards and not just a nice dinner tomorrow. So we're very happy about the interaction, and we're very much looking forward to the discussion. So we're here to present our project PixelQuality, and we kind of want to remind you, we want to step back a few steps. We want to remind you that if we want to have any research insight, we always need data. And in biology, we have several sources of data where our experiments can result in different kinds of data, and just one of them is images. And of course, images are very powerful because they give an insight into the actual physical appearances. And just to remind you about the diversity of what we mean with images, we will just show you a couple. The first one in the upper left corner shows you an insight into a human cell, so we can see the subcellular structures. The one in the middle then shows you an insight into a cancer situation. So images can not only report about the beauty of our cell biology, but also about what may go wrong. The next one is a turtle. It's just here to be cute and to remind you that we can also look at larger structures with microscopy. So we can look at whole organs or whole animals. At the bottom, we see a coronavirus, which is another technique called electron microscopy. So there we can go into much deeper details and structures. And we're not limited to just two-dimensional sets, but we can actually look at three-dimensional structures. So we can look at the whole architecture, and we can also look at time as well. So we can look at an organism or a cell or a structure over time to actually get physiological insights. And I just wanted to remind you about the beauty of science, and the beauty of images. They can be manipulated, but they're also extremely powerful because seeing is believing. Now we are interested in PixelQuality and in the project because there are a couple of issues with images that have nothing to do with fraud and misconduct. In fact, it's just a side effect from several factors. One is that more images are published every single day. So during just my talk, while you're sitting here, we have 25 new publications being released and indexed in PubMed. And a quarter of them will have images. So that means more work for Elisabeth, but also it means that there's just a lot that people want to get out. And most of it, I will just remind you, is correct and is truthfully presented. However, it's challenging. To reach a truthful image in a publication is really challenging. And there are a couple of issues that really kind of arose with digital cameras and digital imaging, and also newly with the AI opportunities we have. And one of the issues comes from image processing, which is a difficult task for every student who's starting to work on a microscope. It's not trivial. So what is image processing? Image processing is that we look at one of those microscopy image that comes out as grayscale. So the first step of image processing that you have to be doing is to actually assign some color to the different channels so that it becomes something pretty to look at. A next imaging processing step might be that you want to know where is the cell and where is the outside of the cell. So that's called segmentation, where you kind of define the outline of the cell. And then another one would be that you can also, I take this off. Another one would be that you actually might want to quantify. So not only look at an image, but to take out numbers of that image. And that could be a question: how large is the nucleus shown in magenta, or how many of the green dots are there? Are there more in other scenarios, etc.? And that's when it becomes really important to do image processing correctly, because in this image you might say, okay, there are around 15 dots or something like that. But with a different image processing setting, you could actually suddenly see a lot more dots. So which one of them is correct? None of them is actually manipulated in a way that I added something or I took something out. It's just a matter of adjusting the properties of the image. So that's one thing that really needs to be trained, educated on, and really is a task for a scientist to get right in order to have a truthful image publication. The other side is that once you've decided what image to use in an image figure, you also need to make sure that it's not just there, but that it's actually understandable to all audience. And that sounds trivial, but it's not, because we did, similar to Elisabeth, we did a screening. So we sat down with a large group of people, we did checkups of each other's work, and we wanted to analyze how many images are actually understandable in current publication. And that was work with a colleague who used to be at the Quest, Tracy Weisgerber. Just want to shout out her. So one of the things we screened was scale information. So scales is a little white bar at the bottom of microscopy images that indicates some reference values. For example, the white bar could be 10 microns, and then you kind of can guess the size of the entire structure. And obviously, we need to know the size of an organism or the size of the object in order to relate it to our microscope image, for example. And so we screened how many of the images don't have any scale information in a high impact publication. And in physiology, that was 24%, in cell biology 10%, in plant science 29%. And then we were kind of, not so quite nice. We also screened for partial scale information. So maybe one of the images had it and another not, etc. So if we take that into account, we see that we have very, very high numbers of images that just lack scale information that is sufficient for us as scientists to interpret the image correctly. So that just was one aspect of the things we screened, but there were more. So all in all, we analyzed that only 10 to 20% of the published images are fully understandable, so that someone who's not familiar with the topic can get that image and fully captures what's being shown. And that could be colorblind, not being colorblind safe, scale missing, some crops or zooms not being annotated, or annotations that are incomplete. So that meant at that point we realized that there's education work to be done. And that's when Christopher and I, who worked for many years together already, teamed up again, kind of in a corona pandemic, when everyone was at home, and realized, hey, maybe there's something we can do. And I hand over to you for the next slides.
Basically, what Helena introduced is where we were like a couple of years back. We knew that there was an issue, basically in the literature. Also from my side, I come more from the image analysis side, and in lots of papers where people obviously used image analysis, there was simply no description of what they did. So you cannot really reproduce their findings or even understand if what the result of this image processing is good. But we believe that the problem here is really that there is a lack of guidance for the authors. There were no guidelines, no unified guidelines explaining these issues to the people and pointing out what to do correctly. And there was also a lack of training. And we knew basically that we would need to go broader than our initial thoughts, because we can only present a certain part of this issue, right? We come only from very specific fields, from developmental biology and cell biology, but biology is much more diverse. The problem, there's also many different microscopy techniques. So the first step here was really to find a community, different people, bringing them together, and that is what we did in 2021, founding a working group inside of a larger organization that is basically concerned with quality and reproducibility in microscopy, which is QUAREP. It's a mouthful. And we basically grew this to more than 150 members now. I checked the numbers in the morning. It's 159 now. And this came from all around the world. A lot of people from the US are excited about this topic. Obviously, Germany is big. But we were able to assemble many different perspectives in this group, and mostly image microscopy experts and image analysis experts, but from many different research institutions like the Max Planck Society in Germany, Harvard, and most funnily also a person working for NASA joined our working group. We also have perspectives from companies, here represented now just as a stand-in white size. And so that was crucial. And what we particularly enjoyed also was the input of journals. In particular, we had a very active editor from a journal. And this perspective really enabled us to formulate this community developed checklist. This was really important that we had these very broad perspectives that we were able to condense in this manuscript here. And one crucial aspect is also write these guidelines. This could be just a bit tedious, like a law text. We had to provide this by a very easy to use format. And that's the other contribution. We condensed these guidelines into these checklists, which basically give you advice in a very fast way, basically using icons, representing what needs to be done, and a simple instruction. This was very well received. We are at more than 30 citations, 33,000 page views, and we are the #1 of Nature Methods article of similar age. And our guidelines now are adopted by 2 different journals. And the feedback was really good, so scientists, they really were interested in this content to improve their own work. Now, basically, after publication, right, we are thinking now ahead. What do we want to achieve? Now, we want to make these guidelines common scientific practice. How do we approach this? We basically develop open source training material because we believe that authors simply lack the training. We want to widely disseminate these training materials and the guidelines. And finally, we want to update our guidelines to the newest developments of basically the impact that artificial intelligence has. So how we are approaching this? We are still using our existing community and basically develop this training material in a large community effort. We are employing currently cycles of open review, so all the material is put on a website and open source from the get-go, and then we review them together in this community. All the material is provided open source. And with the money now from the Einstein Foundation, we want to organize in-person workshops to accelerate this process. The idea is really to, again, take a large, basically broad perspective from many different people in these different varying communities and condense them into actionable training material. This is basically implemented in this website and with a first version already online, and we continue to improve this. Second step is obviously bringing this to the users, basically, or the audience. In the past, we approached this via giving many different courses to specifically to the scientists, image analysis, facility staff, and so on. But this is a relatively slow process. We want to scale this process up. And we are collaborating with different larger organizations, particularly image analysis consortia, European research consortia, and we want to basically bring this content via these larger networks to the user groups. And one particular aspect, we are collaborating with scientific journals to provide this content. And we have currently a collaboration ongoing with Springer Nature. Springer Nature is one of the bigger journals out there. Has portfolio of over 3,000 journals, 290 in biology, clinical medicine, and health. And we have a trial adoption of our guidelines now with the Nature portfolio. And we will meet in end of March now in a symposium to discuss the current status of this trial adoption. Now, we have seen basically, and that comes for the outlook, where these guidelines are going to go in the next few years also. We've seen in the last years undoubtedly the impact of artificial intelligence, that its potential, its pitfall, and also how it can accelerate the scientific process. And I want to show you here more as a positive example here what artificial intelligence in biology, in microscopy, can enable here. And here I show you a flatworm. This is a live imaging. Also this is one still from a time lapse. So this animal under this microscope lived. And the challenge here for imaging such organisms live is that you have to image it with very low light. Otherwise, you kill the animal in this process. And this produces relatively, so these low light conditions you see on the left side here, basically produces low in signal images. It's very noisy, it's very hard to interpret and also analyze. And on top of that, you see these striping artifacts. This is an artifact of the imaging process. This is unavoidable because you have to tile because the animal is so large. And with the help of image restoration process, this is using content-aware image restoration process. So deep learning is behind, so what people may say artificial intelligence. We are able to reconstruct the signal from these very noisy images, and this enables analysis. And you can really see the results in this zoom in, where you practically these nuclei and the cells were undistinguishable. But with content-aware image restoration, you're really able to reconstruct the image. So that basically AI here in that sense is not the enemy. It's enable you to basically achieve something that you couldn't do before. It expands this envelope of microscopy. So this is our friend. These methods are powerful, yeah. However, we need to use them responsibly. We need to also publish them responsibly and make these methods transparent. And we want to move basically our guidelines into this space and basically use our existing process and develop guidelines for usage of this as AI in this particular aspect here, right, for microscopy and image generation. So we want to review the current status in publications. We want to work with the affected communities and also other stakeholder communities, developers of deep learning, to basically assemble a team again and then expand the guidelines to implement the best practices for using of AI. And with that, I hand back to Helena, which gives us a more evocative outline for where we are heading in the future.
So just 2-3 minutes, not that much longer. So we're wondering, like, are we going to be done, right? If we have guidelines and education material for how scientists can publish images and publish them faithfully and truthfully, are we going to be done forever after? Probably not. Right? Because as we look back into the science history, we see again and again and again shifts that are happening on the technology side. So we have brand new methods that are really challenging us to go forward, but that also means that we have to again and again readjust how we deal with these technologies. So I think it's going to be an ongoing process that we again and again have to decide how do images best communicate scientific data. And why am I so confident to say that we're not going to be done yet? Because if we just look back when images in photography were introduced, we can already learn from that. Sorry, that was the wrong direction. So if we look at the very, very first photographs that were published, for example, here in Nature one, and one of the first videos that was published as well a little later, we see them that they're good for our standards today, but already then there was a lot of debate whether they are at all necessary, for example. So in 1910, Benjamin Moore in Nature published a commentary that figures are a total waste of space. He was absolutely against them ever being included in a manuscript. And his reasoning was, we all know what they look like anyway, so we don't need the evidence, right? And that was probably a valid point at that point, because they all worked on similar model organisms, so they all made similar sections. They all knew what they were talking about, right? So that's how progress is done. But if we look back a lot more, there were already instances when we had agreed on how to communicate images a lot earlier. And now we jump back a lot earlier into antiquity. And what we see here is an illustration in a medical textbooks. So medical textbooks included biologists like us. And what we see here is a transcript, but it was actually done before our new time. And we can see in this image that these are like different kinds of scorpions. And if you pay attention, you'll see that they're all annotated. They're all aligned, so they all face to left. So they had some standards on how to present scientific images or as illustrations, for example, in these textbooks. And similar, if we look at the beautiful, beautiful images of Merian, some of them are just hung up or used as tablecloths today, right? But they were scientific evidences because they had a very strict way of making sure that the size was known of the objects. For example, little butterflies were included, and also at the beginning of a book where she published these drawings, she indicated how the size was measured and how we could deduce back the size of the prints shown. So when for 2,000 years there were illustrations, people had come up with guidelines on how these images could be faithfully telling scientific evidences. The big shift happened when we moved from illustration to photography. And that kind of reminds me a little bit on the discussions we're having today about AI again. So here's an example from Arthur Worthington. So Arthur Worthington kind of was living at that jump. So he was initially using the human eye and making drawings of falling water drops. And you can see them on this side. And they were idealized water drops. So he looked at them with his eyes and he tried to recapitulate what he saw. But of course, that was always a merged image in his mind. And they're great because they kind of represent an ideal. So they're a statistical mean of a water drop. When he then did the same experiment with the first camera that was available to him, he was completely shocked. Because the machine captured images that were not at all similar to what he had observed before. And that kind of discrepancy was very drastic, and it sparked in the whole field the debate of what is actually objective, which images can we trust, the one that an educated person had actually gone through and come up with a conclusion, like his drawings, or the one generated by a machine. And at that time, this sparked then a debate in the scientific community of which one should be used, but it also sparked a debate of having to educate a young scientist. And that's the last slide I have. So Neuhaus wrote very first textbooks for microscopists, emerging microscopists, and it's in German, but Elisabeth knows enough German to understand it. So he writes that some photos give the impression that the silver layer only serves as a base for the color of the retoucher, but it should be different in microscopy. Hardly any other opinions have ever been expressed than that retouching should absolutely be avoided. So he was already very clear that no retouching should ever be done to a scientific evidence. And I very much encourage all of you to go to his microscope book. It's available in the Internet Archive, and it kind of reminds me of what we educate today still when going forward to the next evidences. So with that, I would like to end. Thank you, saying that we, of course, continue Pixel World, but we also want to broaden it because we know that we have to work towards generally better data visualizations in biology, not limited to only images. Thank you very much.
Thank you very much. I think the next slide will already lead us into the discussion. Also, thanks for the science history excursion. We have now, I think, time for discussion, and we have actually, obviously, the possibility to do this in this room, and I'm sure that some of you will have questions, but we also have questions via Slido, and those that are online are now invited. We already have one question. But let me see whether someone's here. Let's start in this room, and then we'll try to switch to Slido. And I want to encourage you, when you're sitting in front of your computer, please use Slido. You also, I think, have the address here on the, do you? How do they find out where they? So, okay, let's start. So.
All right, thank you very much. First of all, thanks to all speakers, great presentations, great insights. I want to specifically ask something to Brandon. Not sure where he is. Oh yeah, hello. I find this very intriguing to see how the discussion process works on your platform. Next step is that a way how we could extend or expand these capabilities of that platform to get rid of peer review or to change peer review? What are your thoughts, observations, experiences in that direction?
I mean, this is the real issue is just getting enough people to use the website. But yeah, if I mean, my dream, like Ulrich mentioned in his introduction, is that if we just have preprints and we have community evaluation, we don't need journals anymore. But to get there, we need to have enough people participating in the post-publication peer review. And so, I mean, that's absolutely the goal of the website. That's the goal of the $1,000 awards that we're implementing from the Einstein Foundation. And yeah, I think it's the ideal. I think it's a long ways off, but we'd love to get there.
There are questions. Before we get to you, I'll just ask a question that came in via the internet, and I'm not sure, but I think it goes to Elisabeth. And I'll just read it to you, anonymous, so it also allows anonymous questions. It's not from the Tree of Life. You mentioned the potential advantages of using AI for copy editing texts for non-native speakers. Should we reconsider ownership of wording versus content? That's a difficult one, I guess.
A good question. Oh my gosh, ownership. Well, I think it's important when you use AI. I mean, you still need to. I think you still need to review the text. If you ask AI a question, you can ask it in such a way that you perhaps leave out things. So maybe you should share the prompt and also review the content, so that as the owner of the text, you should be held responsible for the content of the text you generate. Not sure if that answers the questions, but I do feel that at some point, ChatGPT and other generative AI text tools are here to stay. We're going to use these more and more. I know I have played with it a lot. And I think maybe there is a future where all of us will write our papers by using AI, and maybe that would do a better job than a human. You could actually ensure that you mention all the reviews and all the papers and all the questions, and make sure that you include all the references, that you address all the potential problems. I do think computer tools can help us greatly with that. And like I said, you can also use it to make make the playing field equal for all people, even if English is not your first language. So I'm not against using AI as a future tool to write our papers, but currently we're still struggling with that. Currently it's not allowed. You have to disclose it if you use it. I haven't really seen any disclosures. You cannot use AI as an author anymore, but I think most of us have used it.
It's interesting. I checked recently, very recently, I checked like 20 major journals in their guidelines with respect, but the only thing that's consistent is like you cannot use AI as an author. All the other recommendations or guidelines in there are not very practical, I have to say.
No.
So, and I've not seen a paper that says, because those that tell you about it, they ask things like you should give the prompt and exactly the version and all kinds of things. I mean, it's not very practical. So
no, I think it's relatively new technology, and journal editors are not are still having discussions.
Yeah. I think there's a question. Sorry. Okay, so we'll get there.
My name is Stephanie Haustein. I'm a associate professor at the University of Ottawa, but I'm actually here for my sabbatical in Berlin. I really enjoy your work, Elisabeth. I've been following it online. I have a question that's mostly for Elisabeth, but also a little bit for Brandon. And I want to follow up on what Uli actually hinted at with his very personal opinion. For example, the influence of for-profit publishers' motivations on publishing more and more and more. It used to be that publishing space was scarce, in the sense that with every additional page printed, there would be more costs. So journals and publishers would apply pressure to editors and boards to be selective. And a high rejection rate is usually something that journals strive for and that publishers show off with. At the same time now that we see the model with the article processing charges for open access, which in my personal opinion is the way that the publishing industry corrupted open access, by the way, we see the opposite motivation. With any additional PDF put on a journal homepage, they potentially charge thousands of dollars, and we see this with I heard we're also sponsored by Nature tonight. Springer Nature or Nature charging $10,000, I think it is now, for a hybrid publication. So this is actually a research project that we just started with funding from the Volkswagen Foundation, where we're looking into the repercussions of open access on research assessment. And I wonder, in your work, and maybe also to Brandon, what you mentioned with maybe we can do away with journals altogether, but is it maybe do away with publisher or for-profit publishers altogether or move towards diamond open access? Because I think we're really starting to see clashes of academic motivations to communicate science and to advance science with companies' motivation to make more money. And there are more and more interferences too. We know we have journals now where editorial boards step down. I'm on one of those boards where we left Elsevier and we're now with MIT Press. This is quantitative science studies. And we're seeing these clashes where publishers have the first goal of making more profit, and I think this goes to the disadvantage of the scientific community, and I wonder how the fraud plays into that.
Mm-hmm.
Sorry for the very long question.
No. I mean, I share your concern about the rise of open access fees to the point where, universities get less and less money here in Germany, in the Netherlands, in the US, as we've recently seen. So there's less and less money for publishing, and while publishers make more and more profits. And so I think there's now a disbalance. And of course, I'm grateful for publishers sponsoring prizes like these as awards. But I'm concerned about that, because I don't think it's bad and really bad by itself to want to make money in the publishing world. But I do think that with asking money for a product, under the disguise of this is high quality, you also then have to have a quality control, and you have to have customer service. And I feel that those things are lacking a little bit in most scientific publishers, where we still see sentences like the ones I showed you, where this is, as an AI language model, I cannot help you with that. How can that still be published in 2025? That is just a lack of quality control. And also customer service. If I write to a scientific publisher and say, I see some image troubles here, that nothing seems to happen after I send that email. I mean, that is just frustrating. And I usually draw the comparison, like if I buy a very expensive car and it breaks down after a week, as a customer, I expect to then go back to the dealer or the manufacturer, and of course the two of them can fight who's responsible, but I do expect that my expensive car then gets fixed, or I get it's under warranty. There doesn't seem to be anything similar to that in most scientific publishers. Paper mills, I mean, it's up to a team of volunteers who discovered these problems, and still there's many papers that have not been retracted, even though there's clearly problems with them. So I do feel there's a big room of improvement there. I do think that scientific publishing costs money, but maybe there should be a cap, because science is paid for by taxpayers, and why does, in the end, a lot of that money that we get as scientists from grants has to be spent on scientific publishing, and I think something goes wrong there. Can we work towards a model where it doesn't need to cost $10,000 to publish a paper? I mean, you can publish on bioRxiv for free, so I think it only costs like maybe effectively $500 and not $10,000. We still want to publish in Nature. There's a lot of prestige to publish in high impact journals, so we want to pay for it, but we need to have discussions whether or not that is a good use of taxpayers' scientific money.
Brandon, do you want to also comment on this?
Takes a second. So I think this also comes down to the misplaced incentives. The fact that we are rewarding article volume and impact factor means that there's a huge market for this, and so a lot of people. I mean, there's an incentive for the publishers to publish more and more articles. Exactly, and so I think what really needs to happen is the shift in incentives to article quality away from quantity and where it's published. But I mean, so the journals do. I said that in response to the other question that it would be nice to get rid of journals, and I think that's mostly true. But the journals do serve one thing, which is curation of. It's nice to open Nature and have a selection of articles that might be interesting to me in this huge volume of research right now. But I don't think this has to be led by the journals either. I think we can do this easily as a community as well. We tried to do this with PubPeer. You can create kind of like Spotify playlists of articles. You know what other you can find out what other researchers are reading. So I think that curation thing we could create, we could solve as well.
So keep the microphone on, because I'm going to read a question from the online audience, and then we have a queue of questions. But there's a question for you, and that's: are there any plans to authenticate expertise? How do moderators know who is expert enough, or what comment is valid/not valid?
It's a good question. This is a main principle of PubPeer, is that you have to read the comment itself. It doesn't matter if who's leaving the comment. It's the content of the comment that we find interesting. So there can be people who are not recognized as experts in an individual field, as authenticated as an expert in that field. They can still leave a very good, insightful comment that is important for other people to read. So that's my response to that question.
I think the next question was here. But yeah, you're on record.
Thank you very much for all the three very insightful and fascinating talks. My question is to Brandon. There are two parts to it. The one is, do you think that if the anonymous comments would be not that anonymous, but you would know who these people are, that there could be an incentive system built out of this, that there's this expectation that people have to have 50, 100 comments on these kind of sites before they can become professor or whatever. So this is something you have to engage with literature and leave comments before things happen. The other question was, you concentrated on comments where you identified problems. Now, I did my last journal clubs in the last millennium, so that's quite some time ago, but there were always two parts to comments and things we discussed. The things where, yes, there were problems in the paper, but there were also things where you could see that decisions had to be made because life is not ideal, and then you can approach it this way, that way, or the other, and sometimes you need to make decisions and then you go down one road. So the discussion on how could you do it different, or why did they do it, and what are the good parts of this decision? Because when we replicated some of the work, then we found if you do it the other way, it doesn't work at all, or sometimes you have to make compromises. Now, to what extent do you think there should be a balance between helpful discussions concentrating on positive aspects and discussions on problems or fraud or things like that, or more negatively connotated discussions? Or should it only be, oh, I have a comment on this and this means a problem for me as an author?
Right. Trying to remember all of your questions. So, so the first one was, remind me what it was again?
The tracking of
right.
comments as an...
Yes, so we do allow people to come back and keep their same username, right? So they're still anonymous, they can keep it. they can identify to us at some point to say, and this has happened, somebody has said, look, I've written all these comments, I want to show to my department that I've written these comments, is there a way for me to validate that I own this username? So that is possible right now. I love your idea of incentivizing comments. I think that 50 comments to become a professor, this is maybe a little bit extreme, but I like going in that direction. And so then your last question was about positive comments. I mean, they're not, we're not setting any sort of threshold for the number of, or the ratio of positive to negative comments on PubPeer, but the vast majority of comments on PubPeer are negative. And I think there's a good reason for that. I mean, I wonder how useful a positive comment really is. I mean, well, an anonymous positive comment is useless, right? Because that's going to be my wife saying that my work is wonderful, so I think that's kind of, although she probably wouldn't do that, but you see what I mean. But then signed positive comments, they become a little bit more useful. But even there, we're living in a world right now where everybody is trying, every honest scientist is trying to publish their work in the most reputable journal possible. To do that, they're putting the most positive spin possible on this observation to get it into Nature, right? And so it's kind of difficult to say something more about an article than the authors have already said about it themselves, right? Because they're already trying to get it into this best journal. And so to say something even more positive about it, this is a little bit pessimistic, but you see my point is I think that it's already spun very hard to get it into the best journals, and so it's more difficult to say something more positive about it. It does happen. There are useful positive comments, but they're maybe not as useful as, look, I see this is wrong and this is provably wrong.
Thank you. The beauty of the internet questions are that they're very brief, and that's why I'm giving you another one, and next one will be Bernhard Zabel up there. So an anonymous person at the from Slido asks, and that's also going to you, maybe you can speculate on it, why don't journal websites have comment sections directly below their papers, both for concerns and constructive criticism, ideas, etc.? Some have, in fact.
Well, it's a product, and they don't want people saying bad things about their product. They have had sections. They have had comment sections. Journals have had that, and it didn't really take off. It didn't get used a lot. I think it's, one of the advantages of something like PubPeer is this is all centralized. If you have a question about a researcher, you can go to PubPeer and get the kind of community assessment of that researcher. You don't have to go to journal to journal to journal to journal to find out what that assessment is. I guess I'm talking to the camera.
I forgot to say in the beginning, so let's please identify yourself, and we're now trying to keep the questions short so that we can have more of them, because many people in the room have questions.
Yeah, my name is Bernhard Zabel. I've been worrying about the number of fake publications in the literature, and the number is concerning. I have a question not to the speakers, but to the audience. Now, if you push the button and you can start publishing scientific papers, again, a new idea, how is your willingness to switch from the current model to a new model that includes some of the thoughts that we heard from the lectures today, that is a public server that you can comment on? It is non-profit. I know you wouldn't now maybe consider that to be of high value, but if all the scientific organizations got together and say, look, we're going to restart, and it's going to be non-profit, it's going to be commentable, you can download it, you don't have to wait a year to get it approved. I want to do, I'm an experimental psychologist, so I want to do a little experiment with you now. Please raise your hand if you like to stick with the current model. Raise your hand now.
Wait, can I add
now,
one? Can I add one clarification to that? So does this, will this still count for my career if I publish in that?
Yes, of course, because if the scientific organizations support this as a qualification criterion,
Okay,
to
that's
be
important.
published in a format that can be commented on freely and not only by 2 reviewers. So can I now ask the second question? Who would be in favor or willing to switch and be flexible enough to say, okay, if that's what the scientific organizations are asking, we would go for it and we would support it. If you believe that, please raise your hand now. Okay. I guess it was a little shy. Not everybody wants to expose themselves here, but just think about that experiment in your head going forward. Thank you.
Maybe you can sign up outside. Okay. So it's very hard for me to keep track, but I think you were next, and we're moving on this side. Oh, sorry, you'll be next.
Hi. The quick question to Brando. My name is Maddie. I'm postdoctoral researcher in the project Nanobubbles. And I would like to know what is the criteria of a good comment? What counts as a good comment for you for award $1,000 award?
I mean, a productive comment that, I mean, this is, so we kind of look at them as they come in, and so far we've selected comments that add something new to an article, right? So it's not just observational, it's bringing some new information to that article. That's kind of our threshold. But, you know, we've given away 3 of these, and this is kind of evolving so far. But that's our main guiding principle at the moment.
Next question is here.
Hi, I'm Jan. I'm from the Berlin School of Integrative Oncology. I have a question to any speaker who would like to take it. What can we do at research institutions like medical centers, university, to cut down on, you know, errors, on fraud? Do you have any recommendations, any thoughts how institutions could probably lower the chance of you know, faulty papers getting out there? Is there something one could do at the root, at the source? Do you have any thoughts on that?
Helena has.
Yeah, I think it's very clear because Chris and I, we're teaching workshops since 15 years. And we get very, very basic questions from the students in a room, and we open the questions to very basic ones, so we make it a welcoming experience. And it's very clear that there's no training to actually add a scale bar to an image. There's no training how to write a paper, and there's no training at all on data visualization on how to produce a legible graph. So that is completely missing in the education system, both in medicine. I worked at the medical faculty for 7 years, as well as in biology, where I worked for 15 years. So I've not met a single person that had this as an undergraduate training or graduate training. So if we don't teach it, we can't expect them to miraculously know it.
I can also add to that because I was at the meeting of ombudspersons in the Leibniz organization. And they discussed a case with one of the Leibniz institutes where there was a fraud case, and it affected the lab of a director, and he couldn't produce the images. He didn't save the images of his publications, and there was basically the way they implemented this, they added from the institute side a pre-publication check, where you need to not in terms of content, but just that all the material is available saved, and so images, plots, blah blah blah, so that it is at least available. And if you would follow this process, I mean, this is one controller, quality check, right, the sanity check of the publication. And if you combine this with training that Helena points out, that you can raise the awareness and the quality, and at the end of the message was also, because this is an intrusive process, right? You're putting more work on top of people. At the end of the day, once people got to basically understand how it works, and they actually said they really enjoyed the process because it really gave them opportunity to basically improve the quality. So people are open to it actually. And once implemented, trained properly, I think it can also help others.
I'll just add one more thing to that for Boris, since he doesn't have a microphone. microphone, I'll add it for him, that if we instituted publishing the data with the article, this would make it a lot harder to cheat and would also focus people. If you know your data is going to be published with the article, the incentives for cheating also decrease a lot. So I think just publishing, instituting that the data have to be published and open with the when the article is published, I think this would go a very long way, and I think institutes could they have a lever to turn there to make that happen.
Last question up there, because we have a reception directly afterwards, and if you have more questions, you can ask them directly. But last question goes to you up there.
Yeah, good evening. Thomas Bode from the Center for Space Medicine here at the Charité. I'll make it very quick so we all get out and have some drinks. For those of you who have worked with publishers, when you hand in your PhD here at the Charité, you have to submit your document for a full plagiarism check. I have never had this sort of scrutiny in any of my following scientific papers. And you've today shown that we can do automated checks with images. I'm sure if you publish the data, as you've just said, we could also do automated checks on, like, is the data actually plausible? Does the statistical analysis make any sense? Do you think that some publishers, maybe not all, but some of them, would be willing to enforce those automated checks as a way of distinguishing themselves? Or would you say there is a feasibility to have that available, made to PubPeer or whatever, free of charge? Because I, as a researcher, I'd love to have that on all of my papers, and I'm sure a lot of others would too. Thank you.
Who wants to answer?
Yeah, I can. I know that most publishers check for plagiarism, like the hardcore verbatim type of plagiarism, and several have also incorporated either Proofig or Image Twin or some of the other tools into their manuscript screening checks. Statistical checks, I don't think that there's A, standard tools for it, and B, incorporated into the standard processing of an accepted manuscript. So that part is, as a peer reviewer, you can ask for it. So very often there's a checkbox of like, I peer reviewed the paper, but I don't quite understand the statistics, so it needs an additional check. I always hope that that does happen, but I'm not quite sure if that actually happens. I completely agree, and that is part of what I mentioned earlier. It should be part of the quality control. Like if you buy a car, you hope, you know, the brakes work and the airbag will deploy at the right moment. So you expect certain things to have been checked. I think for if you pay $10,000 for an article to be published, that should be checked, but I don't think it actually happens to the extent that we all want it to happen.
Thank you very much, especially, of course, to the speakers and our award winners. Thank you also here in the room and online. For those of you who are here, there will be, I think, some refreshments outside. Also, I think an opportunity to learn a little bit about the graduate school. We have some flyers or posters out there. And just a little announcement, we will host or organize a conference on responsible research. Actually, it's an unconference in September here in Berlin. So if you're interested, just check out this website. And I think that's about it. I like to thank everyone and see you outside for those of you who are here. Thank you.